Algebra 2A, this is yellow class. It is April 4. We're going to try and address part of standard standard 2 today. There are only 3 standards, by the way, for this unit. We've done 1 and 3. The ones are kind of straightforward. So beginning to keep 4 today, unit standard 2 today, eats more standard 2 on next time as we go along trying to work on our 6 pages and things of that nature. So, if we're just doing 1 from standard 3, sure, why not make it, and they get to use calculators, so I need to get that calculator for you in just a moment, but they can start writing. Let's try numbers that hopefully aren't too big. Cancel. Just want to move you. And we will do here, we're going to solve this equation for x when, wrong number, when y is 60. Where are you writing this? You're kind of writing this on notebook paper, or in the other class I told them if they wanted to, let's say they want to write, can you use some of this space and split this one in half, and you can put it on here because we're not going to do that much down here below, but if you had your notebook paper, you want to keep filling that in so it can be part of your 6 pages, you could do it there. On this page, it probably won't count as part of 1 to 6, so I'd probably recommend going to notebook paper where we've been taking the notes. I'll pause it for a moment. In a moment, I'll also come around and try and check. I'll do 1 from standard 1 in terms of review. Go from there. Comes. So I'll say the very first thing that we're going to do on this problem. And again, if you're really good at it, maybe hold off. That way, when you get to the difficult part, you jump in. Let the initial parts be for someone. First step. They do that just so that they don't have the problem too easy. So you throw in that y. We should have made it a different color, but we replace the 60 with a y. Someone different. What is the second step that we're going to do there? I heard 2 people sort of saying it there, but we need to get this log x alone, so boom, we divide there. Somebody help me on the calculator. 60 divided by the 120. All right, 0.5. I'll take that. Thank you. And now we're down to kind of this place here where we just have the log x alone. Someone different. Please tell me what the base is. The number that's hanging off of the g on log when there's no number there. 10 is there. All right, you 2 are out. You 2 are out. Thank you for answering. All right, so now we're left with just a few other people. There is a phrase. Now, I don't know that soon remember this, but fine. There is a phrase for what to do when we need to do something with this base, the x, and the 5. I don't know what that phrase is. Switch. All right. So I will write that. Base and switch. That 5 gets switched over to be the exponent on the 10, even though it looks like 10.5. So I'm going to put that 0 there, which is part of the reason they actually usually put a 0 in front of the decimal, so that it doesn't become confusing. Now, what's true is if you didn't write this one down, you want to write this one down so that you can have it as an example. Now, I know we've been throwing in the pieces kind of quick, but I'll leave it there momentarily so that you can write. So the base and switch is the important part. In other words, the base is always the number at the bottom. It's either at the bottom of an exponent. You see the 10 is at the bottom of an exponent. It's at the bottom hanging on to the log. The base is always the lowest number you can find, and you switch it. The good news here is it turns out because the x is on it's isolated, that is on one side of the equal sign and everybody else on the rest, whatever you do over here will produce the answer. If x were up in the exponent, then we'd have to do extra stuff. No, this one is there. This one I am going to check everyone's calculator just to make sure everyone can put it in. Because let's say you get here, but you're not sure how to raise 10 to the 0.5 power, then you're in trouble. I'm asking for the answer, but then I'm going to come around to actually see it on the calculators. Anyone actually can say this answer out loud. What's this one? Okay, 3.6. Oh, there's a 1 in there? Okay, there's a, all right. 3.16. This one, come around and see it in your calculator. Is at 3.16. I'm also going to leave it on the board for a moment so that way you can, as we look at the math problem with a bunch of steps, it's remembering which step to do first, second, third that makes it math, at least with equations. So I take this opportunity to say, hey, if you have a good memory, you get to be good at math. If you have a bad memory, you get to be bad at math. But if you improve your memory, whatever it is, you automatically improve in math. All right, you might start writing this guy, I'm positive. You have one similar to this guy in your notes. Let's do one from Standard 1, and then we'll dig into the new stuff. The new stuff has 3 pieces to it, and all right, the one from Standard 1, I'm going to do the guy who has the letter E in him. This one, and if not in this class, and in the other class, Standard 1, there is a Standard 1 problem that has the letter E. Enough people mess it on up because E seems weird, but again, we'll see what people remember for this one. Let's try. Let's try. Let's try that. I'll put the E in red. Again, I would recommend initially try to see if you can do it on your own without checking your old notes. If you can, then already you're going to be good. But if you get stuck and like, oh shoot, I need to check, then do it there. That's what it looks like. A little bit weird. My only hint is going to be there's going to be a lot of dividing in this problem. Let's see what happens to you. The official instruction for this problem is please solve this equation for T. Please solve this equation for T. If you weren't here when we did this before and you haven't watched the video, then of course it's just a random problem. But for those who are here, let's hope that you remember some. We did more than one problem, I believe, or a new one. All right. Once you answer the question, give somebody else a chance. So here it comes. Hey, what's the first thing we're going to do with this problem? Close. He's going to come at some point, but he won't be the very first thing. Anybody want to help out? Yeah, the 26, so we've got to get that E by himself initially, so that 26, even though it's his next door neighbor, he's gone. He's calculated. Someone say what 260 divided, someone different. Say what 260 divided by 26 is, please. Then thank you. Those people who just answered, you are out. So now you got to listen to others until it seems like, okay, they're not going to be able to answer. Then we'll use it as backup. There's a 23, someone different. What do I do next? Alright, he's out there. Now, yes, that's it. Every single time I do it. Technically, this idea of me dividing E is wrong. It's illegal. But let's do what I've taught you, and then I might tell you one extra thing just in case you're in another math class and they want to be correct. I mean, or I want to give you a hard time. By the way, what am I going to put in front of this 10 and this E, please? Alright, those who just answered, you're out. Technically, and I'm going to ask you to do it, because there might be extra stuff that might mess you up. Technically, in front of the E's, you're also supposed to put L. You see, the thing is, we're trying to get this T down from the roof. In order to get the T down from the roof, you need a ladder. That ladder includes the letter L, as in ladder, as in log. I'm erasing this. I just want to show you technically what I should be showing you. And then this whole top part climbs down in front. And once it's down in front, then we divide the LN on this side and on that side. Extra steps. I've taught it before, and I'm like, you know what? I'm going to take a chance. I'm just showing them what's going to happen anyway. The E's going to wind up on both sides. You're going to wind up with the LNs. I won't tell them why. They'll do the moves. They'll get the right answer. And eventually, some teacher will explain why that has to be as they sleep while he's trying to explain it. So here's the deal here. These guys cancel out, leaving just the our friend over here. We're down now to the very end of regular. Oh, what is ln 10 divided by ln e equal? 200? 200? Okay, or 200s? 2.3. Oh, thank you. 2.3. Okay. And so The last step, someone different who hasn't answered. This is 0.23 times the t. What am I going to do on both sides since it's being multiplied? Divide. We'll get the job done. We do the different colors. Hopefully it'll pop out in your mind. Of course, these two are going to cancel, and then I'll take a hand. But let me say something about canceling, and then something's broken. Yeah. Yes, bro. 2.023. Oh, there it is. All right. Yeah, we're missing a 0 there. You. Which means we're missing a 0 here. You. Which means we're missing a 0 here. Which means 0 here. Hopefully you wrote in 10, so you'll be all mad, scratching it out. Yeah, that's why I think math teachers say don't do it in 10. Let me fix this a little bit because it looks like an R3. All right, so now that that's fixed, by the way though, let's imagine you wrote that 0.23 on your exam, but you have all the steps right. I think I'd probably give you credit for it. Because I recognize, oh, okay, they just messed up there, but they know the steps. All right, 0.23. Final answer, someone who has not answered, but you have this answer on your table, on your paper. Or not, anybody.
100.
I heard 200, I heard 100.
100.
I'm right, 100. All these steps. You gotta be smarter than people out there. They're not doing all these steps. They're messing up somewhere. I'm gonna teach you not mess up on 0.23. Take a look at it. So again, let me go to the beginning. That way, for someone who's watched the video, they know what handout it is. The beginning. Oh, there it is. All right, this is the handout, Unit 4. I'm going to go to page 10 of this one. What does he want them to be able to do? That one, that one. Oh, because I added extra pages now. My thing's going to be off. Let me try something really fast while you guys think about what you can do at home. Try delete this page. I know there's a delete button. That way I can kind of get my pages to match up with yours. Whoa. Did I just delete a bunch of pages? Anybody know how to... Oh, when I see one of those pages, I delete it. Let's delete you and see. Alright, close enough. Hey, what do you need to be able to do today? You need to be able to draw an airplane taking off. One of the things that you'll need to be able to do is draw an airplane taking off. They'll go from your left to the right. You'll be drawing the graph of an exponential function. Okay? So one, will you be able to do what we requested today? 3 things to do. One of them, everybody can do. I don't care what your status is in math, you can do it. Airplane that will be taking off. The only thing you'll have to learn is it's going to break through a wall when it takes off. Where it hits the wall is part of the math part that, well, some students will be like, what? Where's that? So step 1, where does it hit the wall? No big deal. The letter A is what we're going to call where it hits the wall. Eventually we'll call it the y-intercept. But for now, no math talk, just airplane taking off. Where does it hit the wall? 2, what's the other thing we need to do today? You're going to need to know how to write out the equation that goes with that airplane taking off. So, if you're given an equation, draw the airplane, we'll get the A, boom, that's 1. 2, eventually, we're like, don't give them the equation. Make them get their own equation, and then draw an airplane taking off. And then the third part will be, when you see that airplane taking off, what's happening on this side of the wall? Like, here's the wall. What's happening on this side, and then what's happening on that side? Those 3 pieces is my goal. Then I'll give you an assessment that will ask you, please write an equation, draw an airplane, and tell me what's happening on both sides of the wall. We'll see what happens. All right, ladies and gentlemen, let's see if we can start this thing. This problem here is not the one I want. I want page 10, which has a 4. Did you? Yes. Step 1, let's draw an airplane that goes with this one. We'll do math language at some point. Here's an exponential function. Hey Thomas, please write out the picture that goes with that. But before you do, let's start here. This ground here will eventually be called an asymptote. I will tell a little story about a party to put that word asymptote in your brain for hopefully the rest of your life. Nonetheless, an airplane takes off very close to an asymptote, and then it flies off through the air. So you draw that picture, you draw that, boom. One of the three things done. Yeah, give me your test right now, draw an airplane. Right, so here's the deal. I told you where this airplane touches the, or crashes through the y-axis or the wall. We're going to call that letter A. Because it's math, they need to give a letter. When they ask you to write out the answer, they'll say, write it as an ordered pair. This point here, where it crashes through the wall, which is point A, has to be written as an ordered pair, 0, comma A. That's how you write the coordinates on there. So right now, hopefully you can feel like, already, I got one of the three already. Every exponential function, and I do want you to circle that. Yeah. If you had a highlighter, I wish you would write this thing right here. The exponent x, I wish you could highlight that one. Do I have part to highlight? It is an exponential function. If x is to the exponent, see the word exponential? If you take x out, it's exponential function, which is nothing. That's nothing. You're just crazy if you say that. But if x is in the exponent, if x is multiplied, you have what is called an exponential function. Now here's the good news. Every exponential function has the same graph. Here's this airplane taking off and going through the wall. Eventually we forgot how to find out where did they go through the wall. So let's have them, see if I can have them draw another one without them knowing anything, and then we'll back up and have it go to the wall. So what is on page 11? Is 11 another one of these that allows them to draw? Yes, it is. Let me ask this question. Somebody may already know the answer, and you just heard it. How can you tell that this equation is an exponential function? Say again? There is an x, but where is that x? X is in the exponent, so let me show why I had to do that, and then we'll have you draw the picture here. If I can get back to that very first page with the 7 on it. This equation, what page is this one that I just went back to? Page 1, page 2? And then we'll back up to whatever that page 11 again. This is not an exponential function. You want to tell why this is not an exponential function. No exponent, that is, the x is right, a next door neighbor, 7 times x. It's not 7 raised to the x power, so not. This is, I'll put a no here. No, yeah, sure, no exponential function. Then we'll go back and draw pictures. Exponential function. The abbreviation for function is FCN. Write that down. And I'm going to take you back, and we're going to go back and going to draw the airplane for that fraction. Now, some of you who are afraid of fractions, so write that down. Some of you who are afraid of fractions think it matters, but it doesn't. As long as the x is in the exponent, you can draw the same airplane. We're going to draw the airplane taking off, please. Crashing through the wall. You're back to page something, page 11. You're back to page 11, you're drawing the picture. If you forgot what the picture looks like, back up to page 10. So you might be thinking about, wasn't that a 4? And now this is like a 1/3. Not for what that looks like. It's like the same thing with an airplane. You could be riding on Southwest, you could ride on American, you could ride on a little small airplane. They all do the same thing when they take off. Alright, let me draw my picture. Now we're as smart as each other. You're as smart as me. I'm as smart as you now. Go ahead and put in your A. It makes it math. The A has to be there. The coordinates 0, comma A. That has to be there. The little airplane thing that I have a 6-year-old. He could draw that. So he wouldn't qualify. Alright, so okay, Thomas, we've got the airplane. You can draw it anytime. As a matter of fact, let's go ahead and finish the picture on another page. They didn't quite finish it, and I think that was on page 4. They had their airplane almost like crashing into the ground. We need to fix that on page 4. So now you're an expert, where you can go to page 4. You're looking at the picture they drew for their exponential function, and you're fixing it. Question on my head, well, what's wrong with that picture? Eventually, when we talk about this thing called an asymptote, you'll find out why this picture crashing into the ground, no good. Every exponential function, go ahead and see if you can fix that thing. Yeah. Alright. Okay, so we can draw the picture. Let's take let's put in the A, please. Whoops. Put in your A. A is where it crisscrosses the line, also called the y-axis. Alright. So what do we have now? We have that. Now they need to know the formula. Start with the formula here? Sure, let's start with it here. For every exponential function, there's a formula. It's y equals abx. Y equals abx. You will have to create one of these, so we're going to create a bunch of them so that you feel comfortable. So like right now with the airplane, when they say, please graph the function, I think most of you should be fine. All right, I'm drawing the arrows going up. Got it. Technically, I'm going to add this technical part. I didn't add in the other class. Technically, for those who have a good memory, this side, see up here how it has an arrow up there? This side technically has an arrow as well. If you didn't put your arrow there, I'd still be okay with you, but just so that you're technical, like, I got it exactly right. In any case, here is how you write it. Y equals a bx. This is a puzzle. Those who put puzzles together, there are some puzzles that are 500 pieces, some puzzles that are 100 pieces. There are some that are 1,000 pieces. This puzzle only has 2 pieces, the A and the B. The Y, you don't have to change it. The X, you don't have to change it. They're going to give you a paragraph, and they're going to tell you all about some animals. Somebody has a certain amount of money, and it doubles every year. There are 10 frogs, and they triple every year. The question is, which of those numbers will be the A, which will be the B? Step 1. B is always connected to the exponent X. So when you're looking at this, which one is A, which is B? If you were looking at this one, then we know that, well, I'll ask, what number is B in this problem? Yeah, it's a really big deal. Math is easy. Here comes the hard part. What number is A if there isn't A in this problem? X, good guess, good guess. 1 is the right guess. It turns out, this is one of those cases where when they don't write it, and I wish you had a different color you can squeeze it in, 1 times 3 to the X. So here's some good news for you. If everything just give you a problem with just the B, you automatically know the 1 is going to be the number in front. Now why is that good for us to know? Because the A is what we need on this problem here. You can put a 1 now below that A. That's the place that the it breaks through the line. Now, I didn't draw it to scale. Each one of these boxes will be 1, 2, 3, 4, 5. For our purposes, just draw the airplane. You put your 1 here, and when they actually write it as an ordered pair, you put your 1 there. If the B happened, I would rather that the A was a 10. You put your 10 there, put your 10 there, okay. So let's see, so far, they will ask them for those intercepts. This is called the y-intercept because it goes through the y line. How do you get it? You get the formula and find out whoever is standing in front of the B, and you win. Let's do it 2 or 3 more times, or 2 or 3, yeah, 2 or 3 more times and see if we got it. So let's back up then. Go to page, we started on page, was it page 4 or 10 that we started? I think it was 10 that had the 4 on it, I got it. So there, where are you, 10? We're flipping back and forth because they didn't put all 3 of them in order, which would have been good. Go to page 10. Do me a favor on page 10. Write your y equals abx. Put in what A is, and put in what the ordered form of it. In other words, do page 10. We just did on page 4. So far, nice and easy. In my head, I'm always picturing the assessment. Draw it. They can also put down the formula for what you claim. Y abx. Someone say out loud what A is going to be in this case, please. Yeah, same guy. Oops, I can learn that. Alright, let's see if we can make it a little bit harder in just a second. can't remember what page had the fraction, but I'm going to have you go to that page with the fraction if someone remembers what it was, so that you can see, hey, a little pattern here. Anybody remember what page it was with the fraction? All right, 11 and 12. I'm going to check one of them. All right, so, and also what page is this one? So if someone watched the video, they know. This is page 10. All right. Next door neighbor, do me a favor. Please go ahead and write in the formula right below, and then label it on your picture. At this point, so you're like, all right, got it. It's the same thing. Yeah, there's a fraction. I don't care, but it's what's in front of the fraction. Because whoever's connected to the x, you are the b. Eventually, I'm going to start using some math terms. That's what we're going to use when they ask me. The a, of course, is going to be the y-intercept. Also, I'm going to put in another word they're going to put there, so that when they give you the whole word problem, the a is also going to be called the initial amount. The initial amount is, if I gave you a word problem and said you started off with 10 puppies, and they doubled every month, the A is the initial amount, what you started out with. You had $50 and you doubled your money every year. What is the A, the initial amount? Oh, it's the amount of money you start off with. So, let's take them to the next level. They're able to choose A. What was A in this case, someone?
1.
Yeah, 1. I also got a 1. Now I'm writing down, because I don't think I'm going to fill this thing in. Initial amount. First time we're trying to do initial amount. Initial that you begin with. Under here, I'm also going to write down so that we can make it y-intercept. That's why we're going to write the whole word. Dang. That's really long. Intercept. That's it. The y-intercept. Okay. They'll ask for it in different ways. Initial amount is the way they like to ask it. At least we have the y-intercept there. So what did they do? They probably put a 1 here. They probably put a 0, 1 there. And then you pause it just to see if there's a question. Because now, there's a problem out there where they do a different A. There it is. Do me a favor. Now you are ready to do some whole things in math talk. Please write out the general equation for this exponential function. We just did it several times directly below. Please graph this exponential function and label the y-intercept. In other words, go to your airplane, put in your age where they go, and again, put the equation directly below it. If you're not sure, come back one page and do what we just did there. What I want you to do is say that math, so that you see. Okay, that's how you answer the math. Please draw the graph, graph each exponential function, and label the intercepts, is the way to say it. Properly, and I saw quite a few out there. We got the y equals the a bx. Fraction's not scaring anybody, that's cool. Then over there I saw some airplanes. This airplane here I saw a lot. I actually saw this one here in green, which they went through the 10. They went through the wall at 10 by counting the blocks. Which one is right? I would accept both of them. On an answer key, more than likely to do this one, but because some numbers are weird, I'm okay with this guy here. There's the wall, there's the A, there's the 0, A, there's my 10, there's my 0, 10. There we go. Take a look at it. We're about to go to the next place. This concept I'm about to do now has messed with some people's minds, but let's see if it works. Alright, we're about to do a thing called end behavior. It happened to be here in this one here, and you'll be asked about it today. The end behavior of this graph simply asks, it simply asks this, and we'll start with just arrows. You cut the picture in half, and what's happening to the right and what's happening to the left are the two questions. In other words, if I were to walk along this line here to the right, what is the red line doing? Is it going up or is it going down? It's going up. Thanks for thinking it. How do you write that in math talk? It's going to be the tricky part. Here's how we write in math talk. So just write the symbol infinity on this side. In other words, when we go down this line, we're going all the way to infinity. All the positive numbers, you got a million, you got a billion, it just keeps going and going. Infinity isn't a number. Infinity is kind of like it's a direction. So you're always kind of going that way. He wasn't supposed to be there, but the idea was like the two people need to be awakened. Why not? When I do it over there, it gets louder, but we'll check to see who's on that side. Oh, he's like amazing. No, just hit the wall. All right, here it comes. When x is going to infinity, and that's when we go this right on the x. What is y doing? Well, it's also going up, 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 because up here is also infinity. So here's how you write the green arrows in math column. When I go down this line on the x line to positive infinity, I go up on the y line also to positive infinity. That's what this red thing is doing. When the red thing goes this way, it also goes up. Here comes the other part to confuse somebody. The second question I'm asking for end behaviors, well, what is the red line doing if we went in this direction, where negative infinity is? Like I'll ask it. Hey, as we back up this way, what is the red line doing, going down or going up? Hold that to yourselves. So here's the deal. This one's a little bit of a trick, so I'm glad you didn't answer. Blue arrow. I'm going to put it this way, like this. This red is kind of going down. It's going down. But the way we write it is this. When x is backing up in this direction, negative infinity, this red line will never pass this line here. I'm going to tell a little story in just a moment as to why. But the idea is this. If this is -1, -2, this number right here, which I should have written in a different color, is going to be a 0, then 1, and 2. In other words, let me write down the answer then. Let's see what that's what he's trying to say. The y, this little arrow here, is going to get blocked at 0. It can't pass this line. For all exponential functions, they can't pass this line. And this line has a name. The name that this line has for this picture is called asymptote. Now, asymptote has a definition, and let me see if I can introduce it to you. Hopefully, some of you can start seeing already. Whoa, too much information. I got your whole airplane thing. I got your A thing going. This end behavior thing is going to mess with me. You'll do a few of them. The good news is that you go to the right to positive infinity. That part will always look that way. This y goes to infinity if it's going up in the air. That part always looks that way. So these two, no big deal. To say I'm going to back up, this blue x, it looks that way. The only one that will change sometimes is this y and this 0. If it's the airplane taking off, which is what it will be most of the time, then it will be a 0. The way to remember the word asymptote is a little bit of a story. Let's see if we can include that story. Do I record this story? The story's a little risque, but then not really. But let's put an asymptote. Asymptote. It is a line that a graph approaches. We're only going to write this one time. Oh! But, which is an appropriate word in this case, but never touches. But never touches. But never. Alright. Alright. Asymptote. So again, this red line here, as it's coming down, it's approaching this asymptote, but this airplane will never land. Mathematically speaking, they just keep coming closer and closer and closer and closer, forever, approaching 0. That line is 0. So that's why this one says we're approaching 0. As we go to negative infinity, down this way, down this way, down this way, then from there, the y will never pass. All right. Let's see if we can get some end behavior on one of those other guys. Who's next? Who's next? It doesn't help that all the doggone pictures are exactly the same, but we'll do 2 more of these end behaviors, and then I'm going to leave the end behavior thing, which is one of the pieces I need. I got the drawing that I need. The last thing I need is to have them build an equation based on the word problems. Once we have those 3 things, I give you your assessment, then I'll call it a day. So here's the deal. On this one, please, page 11. Draw the arrows for me the first couple of times. Eventually you won't need the arrows. Break the picture in half as you go to positive infinity on the x line. What is the red arrow doing? Then the second time, if you had different colors, the second one is what happens when you go to negative infinity on the x. What is the arrow doing? Because these exponential functions are basically the same, it's true your end behavior is going to look quite a bit like what I just did, minus the happy music. Alright, that's what I said before. Technically, you need this arrow here because it's coming this way forever and ever. If you didn't have it, I wouldn't stress you to stop. Alright, here we go. Once you say an answer, you're out. Someone tell me for the green, what am I writing on the end of the first x? X goes to infinity, you're out. Second person, y is going to go to what? He's going up forever and ever. That's what this arrow represents. I'm going up and up forever and ever as I go to the right forever and ever. Alright, someone different. Oh, I should have put that in green. Let me keep that in green. Sorry about that. Let me keep those partners together. And then the blue partners. Blue partners. As x goes, someone different. As this x goes to what, please? Negative infinity, thank you very much. The y, someone different, is going to go to what? It's going to 0. It has to stop here. It can't go below that line. It's an asymptote. It's the line that a graph approaches, but it will never touch. Never touch. All right, we'll do this part one last time. See if anybody want to ask anything like, how do you know this? How do you know that? Hey, which guy? I'm okay with that. What page is the one that has the 10 in front of it? There's one problem that had that 10. Oh, there he is. He's hiding. He is page. That's page what? 12. Someone said. Page 12. Thank you. Helps in the video. Page 12. Do me a favor. Please write in the end behavior. This is the last time we're writing it on this. Then we're going to try and find some word problems to see if we can create a y equals abx. Draw the picture. Find the y-intercept. Put the end behavior. Put it all together. So if you're keeping up, that's a good thing. So I already did that one. Find one we didn't do then. Go page 4. I know we didn't do page 4. Where are you, page 4? Where are you hiding? Now, so we can see on this page 4 why that picture's not so good. The original that was there that we helped fix, because that graph went right into the ground, which it never touches this synapse. Now write down your end behaviors, and we'll start building some. The arrows on the graph for me. That way, I know what you're saying as I go to the right, the blue arrow goes up, and as I go to the left, the red arrow goes down, but it doesn't approach. You can even put this now. All right, so let's write that in, and then let's start building. First one, I'm going to look at that frog problem. Can I write it really fast? You go there. You go there. You go to the opposite direction. And there is a scenario where this blue y goes to negative infinity, but it won't be on these pictures. All right, where's that frog? Is the frog next page? There's the frog. So here's the neighborhood you're in. They give you a paragraph, you produce an equation, you produce a picture, you produce a line-intercept, you produce end behavior. All right, so let's take them through the first one. That's nice and easy. Yours will be ugly. By the time I get to the very end, it'll be pretty ugly. But here it comes. If tree frog population doubles, please write down doubles. Circle doubles. If you had highlighted what you highlighted in exponential functions for things to double, it's 2 raised to a power. That power x. If things triple, what number would be there instead of a 2? If it quadruple, Right. So any of those things where you multiply, like I got $2 today, but then I multiply it times 2, it doubled. Tomorrow I got 4. Then I multiply again. I multiply times that 4, I got 8. It's exponential growth, which is what you want with money. That's why they say to you, and I didn't do it. I wish I'd go back in time and do it. If you're 18 and you got a job, you want to put like I think it's like $100 a month or a year. I think it's $100 a year. It's $100 something into the bank. You do it for 5 years, right? 18 to like 23, and you leave it. You never touch it. You just grow up with your life. You do whatever you're doing. The money's growing exponentially. The idea is that by the time you're like 60 or 65, like it's $1 million. So at 65, you have $1 million. You can use whatever. You didn't do anything with it. It's exponential growth. And then you live your life there while you're like, oh, I'm still working. Whatever. You're like, oh yeah, I mean, I got $1 million that I take a little bit of time. It's still gaining interest. I didn't do it. I'm 46. It's kind of too late because you have to start early for it to do the magic. If I started now, I wouldn't do as much magic. But you heard it here first. Consider doing it once you come early 20s. You can even do it. Whatever you get a job, you put ask someone or you type into Google $1 million by exponential growth, and then it'll tell you, oh, put it. I think it's $100 every month or 2 months or it's some number. It's small and just turns into $1 million without you doing anything other than living your life. In any case, this one doubles. Let's see. Suppose that currently there are 10 tree frogs in your backyard. How many tree frogs will be there in 6 months, assuming that there are 4 weeks each month? The bad news on this one, they got numbers all over the place. But here are the only 2 numbers you need. Please write down that generic formula, y equals abx. For your equation, you just need to figure out 2 things. When you figure out one, the other one is there. Now, on the test, they won't have as many numbers. This one, you'll have to be a little bit tricky. So there we go. Hey, how many frogs did we start out with? Whatever you start out with, you have your A. Where are you, 10? So when you're searching for that A, just look, okay, what did it start out with? Start with money, start with whatever. Here's my 10. I got my BX, so that tells me how it doubles, triples, or whatever, and I win. I'll put the 2 in here like that. That's the first time building this. Now that we built this one, I think the next page next to it has a formula. I mean the graph. Go ahead and graph it. Put in your y-intercept and your end behavior. That's what they're going to be asking you. So when you produce this thing, you're ready to go in and do it. So do me a favor, go to the next page. I think it's right next door to it. And go ahead and graph this equation that you just built. Put in your y-intercept as your A. And put in your end behavior. We're going to do this at least 2 more times, but the problem will get uglier and uglier each time we do it until finally it's close enough to... Alright, hey, time to draw that thing. What was the equation? So y equals, it was 10. And then times the 2, because it's doubling. Airplane. A. 0A. 0. What was the A in this one? Oh, it's 10. That was the initial amount. My green arrows this way and that way. My blue arrows, I wish you had different colors, that way and that way. And behavior happens to be as infinity, as x goes to the right. This is how we write in math, as x goes to the right. Y goes up into the air. This is how we write it. And as x goes to the left is where all the negative numbers are. Y tries to come down below that asymptote, but it's not allowed to go past. And that asymptote, it approaches 0. That's what these lines say, it approaches. Which if ever you go to calculus, this is the symbol they'll use. As x approaches, then the limit will be 0. Anything I missed on here? No. We got it. All right, let's do 2 more of these, uglier and uglier, and then let you have it. I'm going to fix one so that the last one we end with resembles the one that you're going to get. So go to the very back. I think the very back, page 15. Let's see. Oh, wait a second. Let me do one that they kind of started for you, so at least you can read the words. We'll just circle it let's do this. Let's circle it so they can see it. Go to page 9. We're just gonna highlight what they have. They did it for you, and then we'll go to the last one. Where are you, page 9? All right, page 9. What does he want to do? He just wants to read the paragraph so you get used to like all the stuff they'll say. Don't be afraid of it. Here it comes. An investment of 5,000 doubles in value every decade. The function f of x equals the 5,000 times the 2 to the x is where the number of is the number of decades. Models. So if you had a highlighter, what I want you to highlight is models. Models is a math word that says, hey, you told me something about real life. I wrote an equation to show you what that would look like. That way I can figure out what happens 10 years from now, whatever. This real life situation has been modeled by this function. What does he want them to see about the function? He wants them to label the a and the b in that function. They have an equation right here in the middle. If you want to rewrite it down here so you have more space, you can. But what is it that Thomas wants you to do? He wants you just to label the a and the b. Now this one they did for you. Normally they wouldn't give you the second one. They just read that very first line. An investment of $5,000. That's how much money you start out with. Oh, it doubles every decade. It triples every decade. So they want to do that. We would just put our y equals y equals. They use the f of x. All right. Let's get to that last page, to the back page. That page should be 15. I feel like I ended it at 15, or did I? What did I go up to? I went to 16. So we're gonna mess around with 16, but I got to change one of the words at 16 to make it look like what we want. The word is decreases. Now this first one is the first one I'm going to let your brain hurt. I'm going to let you read through it. I'm going to let you try and decide, okay, which number should I use? Which one's not? Your hint will be percents are always used for what's called the growth rate. And so let's do something here. 1, instead of decreases, let's make it increases. That's kind of important for a reason that you don't have to think about right now, but just know that teacher wants you to do it that way. And then the last thing is that the percent is usually going to be your b. How much it grows. Do me a favor. Just read all of this. And then write your y equals a. Oh, I gave you y equals a dx. Try and write down what you might guess. This is the test level version. This first time I want you to try it, guess at it, be completely wrong, completely right. Fix it, and then you get a second try, we're like, oh, okay, I don't know. First time, yes. Second time, begins. Y was ABX. I gave a hint that the what's the thing called? It's called the decimal. The decimal, or rather the percent, is going to be the B. So for these, you have to guess that percent. Let's see, you're 11.5. I'm going to hurt your brain with something I'm doing just a moment. But again, this is what you need. In the end, I can't escape it. But just stick to the end so it won't hurt so bad. All right, here we go. What is someone, let's see. The atmospheric pressure at sea level is about 101 kilopascals. For every 1,000 meter increase in altitude, the pressure increases about 1.5. All right. But, what's the guess for what H should be? We got some numbers. We got a 101. We got a 1,000. We got a 3,000. 101 is the thing. Like, so now your version of this eventually won't have as many numbers. It's gonna be a little bit obvious. The thing that we get, like with the frogs, a little bit obvious. The atmospheric pressure at sea level is about 101. For every 1,000, it increases. So it begins at this 101. Very quickly before I tell you, no, I got to tell you the rule that goes with these now, so that when you do this next one, I'm asking you to do. This next one's kind of like your, okay, I know where it begins. I know for percent, that's probably going to be B. Hopefully they don't give me a bunch of other numbers. The last thing you need to know. We won't be able to use the percents in this form. We have to change it to a decimal. Not only do we have to change it to a decimal, we have to add one extra number. that number's going to be 1. This part you have to do right at the end. Here it comes. So technically, for this thing to be written properly, and I wish I didn't write it all on this stuff here. I should have written it where it goes down here. So I will write the finals down there. 1, 2 gives me a. When you're doing a decimal, for those who have forgotten, changing percent to decimal, you only move it 2 times. And the extra piece you have to do is you have to add a number 1. There's a reason for it. Again, I can go all explaining or whatever, but for now, for the purpose of these, here's what the final setup looks like. 101. The percent that we have to turn into a decimal and add this extra 1 in front. Take a look at it. See how it feels. So that means, of course, to see like, okay, do I feel where that 101 came from? Well, I definitely know where the 115 came from. I moved it twice. Where's that black 1 come from? That one. It's just the rule. Even when you're doing percent decreases, get all that money in the bank, you have to do 1 plus whatever this was. If it was a decrease, which is why I changed it, it'd have to be a 1 minus that number, and that'd be a mess. But it just keeps it right up. It's gonna be confused another time. All right, so that you can feel good inside, do me a favor. Graph it. Get the 1%. Do the end behavior. The hard part is getting this thing once you have this in your home free. It is true after we do that one, after we draw that, you get one last chance to have it all come together. Matter of fact, I'm going to start doing mine. I'm going to come around and check on. Start doing mine while you're doing yours, so I can feel how easy it is when the pieces are there. Some of you don't miss the feeling of putting in the A, which you didn't know at the beginning of class. Now you know it automatically. Hopefully you have the good feeling of knowing the end behavior. If you didn't know end behavior at the beginning of class. For some of you right now, you're able to put in end behavior. No big deal. So I don't want you to get lost on like, oh, should there's new stuff I don't get. Remember, shoot, there's some stuff I can do already? Dang. Alright, final chance. Here we go. Last time, then I'll ask everything. Final question, and then just give it to them all. If anything's broken today, it still can kind of be fixed. Alright. Back up to, I think, page 15 has one. But it's on the same piece of paper. Read it carefully. Do the best you can. Of course, do to page 15. What we just did here on page 16. You're doing the whole thing. You get the equation, you're drawing an airplane, or you're graphing the exponential function. No longer will we call it drawing an airplane, but we graphing the exponential function. We finding the intercepts, the A, and then the end behavior. All math talk. We're trying to do the whole thing as a story of the text. The sad part about today's lesson is technically today's lesson is supposed to be coupled. The opposite. There's a log lesson where the picture is an airplane starting down and trying to break through the ground. So it's more like a submarine. It's more like a whale, like Shamu coming through. Unless you saw Blackfish, in which case it's not Shamu, it's something else. In any case, let's try it. Once you give it an answer, let someone else answer something. Big question. Who's A? 360 is A. And I appreciate some of you who did the billion where you wrote out all the numbers. For this purposes, it would be okay for our purposes just to have the 360 there. But if you did the extra 9 zeros that come after that, I'm impressed by you. Someone different. What am I writing for the B? How am I writing that? It is going to be that 7%. Let me put this here, but there's a way we're going to write it. So let me put this growth factor, and I haven't even been using that term for growth factor. So I apologize to you, because they may say, what is the initial amount? What is the growth factor? B is the growth factor. Is it doubling? Is it tripling? How is it getting bigger, or is it smaller? The 7% is it initially, but again, the way we have to write it, someone say it. What's actually going in there? So what I saw on some, here's how you write it as a decimal, 0.07. And then you have to add that extra one, that random one. In math, you're not supposed to say just do random stuff. But for our purposes, rather than trying to explain one other thing, we'll put that in there. There's a picture, look at it. There isn't another one that's coming other than what's going to be on your assessment. So right now you want to see, okay, where do we get the 360? Well, the years, usually you're not using years for the initial amount. Because you're using that percent usually inside here, usually it's money out front or number of things. I'm just going to sketch in the picture because I believe in you in terms of your pictures, going through that really fast. And again, you can see with this 360, which is why I haven't been dealing with the scale. Make sure you, if it's a 1, go through 1. If it's a 10, go through 10. Because if it's a 360, then do what they would say is draw it to scale, which if you decide to mess around with that, maybe make this 100, 200, 300, 400, 360 if I go through here. But again, I'm not that concerned. The student knows that this is going to be the picture. They know that this point where it goes through is point A, which in this case happens to be 360, and they can write it as an ordered pair. Oops, let me write in the A. I'm impressed by you. Whoever the other teacher is was like, hey, you didn't scale it right. And I actually think the assessment may say scale it. You can bring the 360 I want an A there. But I'm not going to stress you on that. If you know how to scale, scale. If you're not sure how to scale, just draw your airplane taking off. My green, this is it. This is the last time. I'm going to let you look at it for about 2 or 3 minutes, maybe even 4 or 5. And then from there, my greens, as x goes to positive infinity, y goes to positive infinity. That's what this side of the picture is doing. It's all going up. If I back up the other direction, as we go through all the negative numbers, again, this guy won't touch the asymptote. There. One thing that some students have done, and I get it, they like drawing for the blue. They'll draw this arrow coming back this way. And I see it, yeah, but no. When the x's go to negative infinity, yeah, the negative infinity is over here, but this is how we say goes to it. So don't put the arrows going back this way.